Good evening and welcome to the Q&A session 18 from the playlist of JEE Advanced Physics. The topic is the projectile motion in the two regions having different values of acceleration due to gravity. So the question here is a projectile is fired from a ground with a speed u and the projection angle is theta. The range of the projectile is d when the acceleration due to gravity is g. At the highest point, the projectile enters a region of acceleration due to gravity, which is equal to g divided by 0.81. So the new range of the projectile is. So this was the question which was asked in the JEE Advanced exam in the year 2022. So in order to understand this question, I have made one simple diagram here. So here this is the projectile which is projected from this ground with a speed u. And the projection angle here is theta. Now the range of this projectile is equal to d when the acceleration due to gravity is g. So in this region the acceleration due to gravity is g, and after this highest point the acceleration due to gravity becomes g divided by 0.81. So at the highest point the projectile enters the region of acceleration due to gravity, which is equal to g divided by 0.81. Now here the formula for the maximum height is equal to u square sine square theta divided by 2g, and the formula for the range, this is equal to d is equal to u square sine 2 theta divided by g. So these are the two standard formulas, and we will be using these two standard formulas in order to find the new range of the projectile. So let us consider the new range of the projectile. Let us say this is equal to r dash. So this will be equal to d by 2. When it reaches the highest point, then the horizontal distance traveled by this projectile will be equal to d by 2, because the range of the projectile is equal to d when the acceleration due to gravity is g. So the new range will be equal to d by 2 plus the horizontal distance covered by this projectile when it enters this region where the acceleration due to gravity is equal to g divided by 0.81. So let us consider that horizontal distance equal to x. So we have to now simply find the value of x, and thereafter we will be able to find the new range of the projectile. So at the highest point, the vertical component of this initial speed, that is u, will be equal to 0, and the horizontal component, that is u cos theta, this is the horizontal component of this projectile is equal to u cos theta, and this will remain the same throughout the projectile motion. And at the highest point, the vertical component will become equal to 0. So by using the equation of motion for the equation for motion in a straight line, that is s is equal to ut plus half gt square. So here at the highest point I have taken the maximum height equal to h, and the initial vertical component of the speed of the projectile is 0 at the highest point. So that is ut will be equal to 0 plus half. Now this projectile has now entered into this region where the g value is equal to g by 81, g divided by 0.81, sorry, g divided by 0.81 into t square. So from here, now here t is what? T is the time taken by this projectile to reach the ground. So this will be equal to under root 2 into 0.81 into h divided by g. Now h is equal to u square sine square theta divided by 2g and here with in the this denominator there is 1g also, so this will be equal to 2g square. So this 2 and 2 will get cancelled out. So finally the value of t will be equal to, this will be equal to 0.81, so this is going to be equal to 0.9 u sine theta upon g, u sine theta upon g. So this is the time taken by the projectile to reach the ground from the highest point. So the horizontal distance covered by this projectile from this highest point up to the ground, this will be equal to, that is x, this will be equal to 0.9 u sine theta divided by g into u cos theta, where u cos theta is the horizontal component of the speed of the projectile, and this speed will always remain constant throughout the projectile motion. So this can further be written. Now here what I will do is, since here the range is equal to u square sine 2 theta upon g, so I will be converting this this value in terms of sine 2 theta. So 0.9, I will multiply the numerator and the denominator by 2, so I will be getting into 2 u sine theta, sorry, this will be equal to u square sine theta cos theta divided by 2g. So this is equal to 0.9 upon 2 into, now this will become u square, 2 sine theta cos theta will be equal to sine 2 theta upon g. Now u square sine 2 theta upon g is equal to d. So x will be equal to 0.9 upon 2 will be equal to 0.45, and u square sine 2 theta upon g is equal to d. So this is equal to 0.45 d. So the new range here will be equal to, this new range, this will be equal to d by 2 plus 0.45 d. So this is equal to, or I will be simply writing the value here. So the new range r dash will be equal to d by 2 plus 0.45 d. This is equal to 0.5 d plus 0.45 d. So this is equal to 0.95 d. So the new range will be equal to 0.95 d, and this is the answer of this question. That is, the new range of the projectile will be equal to 0.5 d. So thank you very much for joining this session. Now in the next session I will be discussing one more question from the projectile motion, and the question will be somewhat different from what we have done today. So till then, have a nice day. Bye.